All right, let's see if we get emails. No. So we're kind of good. Is Johannes here? Yes. Awesome. I think we can just go ahead and start. Yeah, Fabian, do you want to share your screen and then we can just go ahead starting with this session? Alexander is also joining. Hi, Alexander.
Hello.
Like you also wanted to join the debug session, right?
Right.
Perfect. Yeah, the other link.
Right.
Yeah, the other link didn't work, so sorry about that. So Fabian, you're muted, just in case. Yeah.
Oh yes. Now you hear me. Sorry, I was talking all the time.
Oh, no.
Perhaps someone can share the update of the link, or at least the information that we are here in the OET channel, events channel.
Yeah.
I think that would be nice. Yeah. Otherwise, I would start and share my screen, and you also have a lovely look at my buggy Discord.
How should we make it with the interactivity, Fabian? Do you want to present first and then we answer or like ask questions or have them right away? And how long is the session planned roughly?
Yeah, I'd say we keep it open from the beginning. Perhaps I'll make the intro and then we open it up and then we go into the interactive part and we're doing some coding. Yeah, let me just start here, I'd say. Okay, welcome everybody to our debug session, which is the first of its kind in probably a row of debugging sessions that we're having. And today we're going through the very basics of debugging in Python. And I would start with some very basics. And first
Can
of
we
all,
zoom
giving a short intro.
Sorry, can we zoom in a little bit on the screen?
It's already zoomed in.
Yeah, perfect. That's a little bit better, yeah.
Are you watching on your phone? Oh, no.
No, like on the laptop, actually. Yeah.
Okay. Yeah, first of all, I would give a very short intro on why we need debugging, what is debugging important for, and then I'll actually go right into the code. So why do we need debugging? Debugging is a very essential tool for every coder that is out there in the world. I'm pretty sure there's also coders who do not debugging and are still producing very good code, but it's a very essential and fundamental thing to do. Debugging is a thing which you need whenever you have a problem with any code. Code bases might be your own code bases or an external code basis, and you see something is wrong. And you see that while running the code, and then you see an error message. And the normal thing would be, oh, damn, there's an error. The intuitive thing would be, let's keep distance to that. Perhaps I restart my program now, or I restart my computer and see whether the error still persists. But this is not the case how a debugger would approach that. A debugger would really try to understand what is going on there. There seems to be an error in my code base. What is going on there? And then he would try to hunt down, he or she would try to hunt down this error and try really to understand where the problem occurs and why it occurs and how we can solve it. So debugging is really essentially about creating a solid code base and bringing that solid code base to into a better state where we do not have any bugs anymore. These bugs can occur everywhere, even on very low, for us, low base, or let's say very basic packages like in pandas, in numpy, in wherever you might still occur some, you might still tackle some bugs, which are just there because sometimes there's just things going wrong. There's a wrong type. There's an expected object passed to a function which is a requirement that is not fulfilled, in some cases, whatever. So debugging, very essential. And so my goal for this session would be that you become friends with errors, and you can say that errors is actually something we welcome, because they give us very important information on actually what's going on. So Python is a very good language, I'd say, but it's also very responsive in the sense that whenever you have an error, you see what is going on, and you can really there is sort of the easy option to track down where this error is coming from, and the error message is really helping you in that sense. Okay, this would be my intro. I would say now we would go to our first interactive session, but it should really be open. So whenever you have questions, comments, whatever, critics, let's have this conversation, and always also open for complimenting comments and additions when something is missing here. So here we are starting with our very commonly used platform, VS Code. On the left-hand side, you see my folder structure. So I prepared some files here. We are now in the buggy world, where we have some different Python files. They are all very, very nasty. And we're starting here with the bug hotel. The bug hotel is a very short script. And you see here 3 functions. Function A, function B, function C. And in function C, we have a bug. This bug is there, and it will occur as soon as we run function A, because function A is calling function B, and function B is calling function C. So what I would do now is I run this function on the right-hand side in my IPython shell. So I don't know about your setup, and we can talk about setups later. But what I do normally is I have a script on my left-hand side, and I have a shortcut to run script on the right-hand side. So this is what I'm doing. Now let me open that again. And when I'm running this code, you see here we have an IPython shell that opened here, and we're now hitting the bug. We're hitting the error. And now, as I said, the intuitive thing that perhaps some of the people who are not super familiar with Python and errors in programming, that would be try to find distance to this bug and leave the room. But we're now trying to really catch on, to catch what's going on here. We're seeing on the right-hand side now the traceback. Traceback is consisting of different levels, as we see. So here on the very top, we're having our script call. This is where really the Python code is run. And then we're hitting, this is our first level, our very first message, we're hitting an error, which is a value error here. And we're already seeing, okay, this value error seems to appearing here in this line 16 in a script which is called bug hotel, which is apparently the same script as on the left-hand side. And this is actually the line where the error occurs. So, okay, we figured that out. Sorry, we're actually wanting to see only these 2 lines. Okay, now this is our first response from the traceback. The second is something that goes a little bit more into detail where it exactly occurs, which is the functions that we call that led to this error, which is these 2 lines here. So function A is called, and then the value error is raised. So far, so clear? But now there's even more additional information, which is very important, because now we know, okay, there is now this error and it's annoying, damn it, we have to solve it. Where does it come from? And we know, okay, it comes from function A, but it's not directly C, it's not here. We don't see any value error here in function A where we call it. it is somewhere hidden on a lower level, and you all know where I want to go, but it's still important to go through it. It is going through the different levels of our functions. So here in the first level, we're seeing function A is calling function B. Okay, we know that, but still, okay, there's no error. And in the next level, we're seeing function B is calling function C. Still no error, but then we're going there, and we're seeing in the next level here, function C is actually raising an error. Function C is raising an error. And we can directly see where this occurs. This is all clickable links here, so you can click on it. You would be going directly to the place where the error is raised. And you see, okay, this is where the error occurs. Yeah. So what I want to say here is, as soon as we see this error traceback, it is very important information that will lead us to the error, and it will give us different levels of depths in the code that we that all in all go in the end, or target in the end, to the error. Okay, this would be sort of the intro into the traceback. So what I really want to summarize here is the traceback is a very important information, or piece of information, and it has different levels. And it starts with a very, very top error raise, where actually the error is raised. And then it goes through different layers of code depth until we really hit the point where the error is raised in the code itself. So it goes from low level to high level. From high level to low level, depending on the direction now that you follow. Okay, how would we get a bit more detail on these levels? I have prepared a bug hunter, which is this script here. And this bug hunter is now sort of our test pipeline on how we can approach bugs and how we can sort of go through the code in an interactive mode and see whether or how a bug actually evolves. And normally what you or the programmers occur is bugs that are rather complicated. They're complex in the sense that there's different layers of different packages and there's a lot of lines of code. And sometimes it's very easy to lose yourself in that. And this is why I want to go a bit more into this bug hunter, or this bug hunting and debugging interactively topic. So what I would do now, my right-hand side terminal again. And let's start perhaps with function A that we just now discussed. I'm importing here from the bug hotel. I'm importing function A. And there's different other buggy functions that we can have a look at later. But now we focus on function A. And I want to show how I would now approach that, or approach a bug in principle. So I'm running again this script. And what's happening now, I'm again facing this error. I see it's the same as before. It should have an additional layer because we're importing it from another module. You see that here. And it's also pointing us, we're running now in here the bug hunter py. It's pointing us still to the bug hotel where the bug is actually defined or raised in the end. And what I would do now to sort of get a feeling on what is happening, and getting a feeling always comes from interactively communicating with the code, is that I would run here the debug mode. This is a very, probably IPython related function. It's a magic function, but it is sort of hidden, or it builds on the same principle as most of the other debuggers. But it's the one that I prefer because it's very basic and minimalistic. but it's really also your choice what you're using there. But the principle itself stays always the same. And when I'm calling this, we are jumping, or we're sort of opening. We are opening a new sublayer of the terminal, which you see here. It's not now the IPython terminal, which has this starting prefix. We're now in the IPython debugger terminal or shell, let's say. And this is a sort of very flexible shell which can jump to the different layers of our traceback. And it allows you to really investigate on the different levels what's actually your working environment, or what's the definitions of variables on the different levels of your traceback. And as you can see here, we have now entered the level of function C. And you remember there's these different layers, A, B, C, and I can now go the trace up or down as I want. I'm now on the lowest level, so I would go now up just to see, okay, there's different levels. I can't remember what's again the previous one. So I'm going up and I'm pressing U. U is a sort of the command for going one level up. And now I'm seeing, okay, I'm on the trace back on a level which is higher than before. And I can do this one more time. And now I'm seeing, okay, this is function A. Yes, I know that. Okay, but now I want to go back. I want to go to function C again. So I'm pressing D. D and D again. And I'm here with function C again. So this really allows you to move through the code and through the different layers of the traceback. Imagine you have a very complex error and you seeing some weird behavior, I don't know, in a NumPy package, sub-package, and you really don't know what's going on there, but you see there's also in the traceback some link to your code. And what you can do then there is to go with the traceback up until the point where your code is actually focused. And then you can see, okay, what's actually going on in my code? Perhaps it was even my code that was bad. But what I want to say is that these different layers and the flexibility to move between the layers is a very powerful feature. Okay, I'm quitting now. I'm pressing quit or Q. Now I'm back in my IPython shell. I want to show you one more thing. When we go into these different functions, let's define some variables. Epsilon is 33, and we have one more here, 34. That's good. 44. Now I'm running this yet again. Let's go to the bug hunter. And I'm here again. I have modified functions now. I enter the debugger again. And what I want to show you now is that at each level that we are now focusing, we have different variables defined, right? So now we're here on the lowest level, and we have Z defined. Z is 44. You can always, you should probably make a P in advance to the printout of variables. So P is for printing out variables. This works as well, but if it's not colliding with the Python debugger instructions or commands, then you can also directly put out or write out the variable names. So that is defined. Let's go on the left-hand side again to the bug hotel. And now, what happens if we search for Y? And let's perhaps put the P, Y. It's not defined. We have to go one level up in order to show it, right? Because Y is only defined in this level here, where function B is called. Here, Y is a variable. It is not. Or Python does not know about this variable when we are in function C. right? So every function is sort of an atomic structure, and it does not know necessarily about variables in another function. So it's really isolated sort of mini environments here that we are going through, and these can be explored via the debugger whenever you go up in a certain level. So if we go up 2 levels, now we are in the very first level for function A, we have x defined, right? This is just generally on how the structures of the layers play out. These functions could be tremendously complex, and you would really want to have a view on single variables that are larger objects than just now integers. But you can access them in your traceback with this debugger, but you have to be on the right level. Okay, this is then, I hope, clear. I would now go out of the debugging mode and perhaps show you one other approach how to go into the debugging mode. Here, I will send you all these scripts and instructions. Here I have written down some explanations on the debugging. When it comes to the choice of how to enter into the debugging mode, there's different approaches. I already talked about that this is my preferred one, so the debugging call in IPython. But you can also do the following. Whenever you have a function defined and you know, okay, this is raising errors, this is annoying, what's going on there, but I want to really insert in, or I want to go into a certain point, I want to insert at a specific spot, and you can write out a breakpoint. A breakpoint is essentially the same as if you call the debugger and you went exactly to that point, or you set the trace at exactly that point. That was perhaps a bad explanation, but you see what I mean in a second. So when I'm calling this now, I am entering directly into the debug mode. So I again just made a Python call on the script. But what's happening now, instead of hitting the error and having the script run through, I'm stopping at a certain point. And this is the breakpoint. The breakpoint really defines everything up, or lets you define everything up until you hit the breakpoint, and everything below is not executed. So we're really having one insertion point where we stop. And now you could guess, okay, what of these, or which of these variables is now defined? Would X be defined? I say no, because we are on the wrong level. Is Y defined? I would say also no, because we have not yet executed this line here. But we can. And either you do it via really copying that line over and you run it, so you can really execute Python code in this debugging shell, or you do it via the IPython debugger commands. What I'm sometimes doing, because I'm a bit lazy, I'm just running these lines, then copying them over. I have a shortcut here. When I press my shortcut, it appears on the right-hand side, and now I have Y defined here on the right-hand side. Right, so you can imagine that you sort of opened an interactive shell at exact that point, and now you can play around. But the other approach would be to, with the shortcuts or the commands, IPython debugger. And I'm very sorry, this still works. I have to admit that I'm not very sure. N is the next line, I guess. Go to the next line. Yes. So if I press N, and I have pressed N now, it should go to the next line. And now why should be defined again. Let's try that again. So I am quitting this one here. I'm running the code again, and I press Y. I press N now, and probably now Y is defined exactly. So the breakpoint stops at the very point where you defined it, and you would see in the debugging session, sorry, where you are and what's the next line. And this is what we saw here. And as soon as I pressed N, this line which we see here was executed, and then we're seeing the next line. Okay. Are you still there? And are you still there? And is there any questions so far? No.
But we are there. Yeah,
Oh.
we're still here.
Very good. Okay.
Hey, Fabian. Maybe one question.
Yeah, sure.
So for those listening who maybe don't know how to define a custom shortcut to execute your lines in the IPython shell, maybe it would be helpful to show to show this.
Would it be fine if we keep that for later?
Yes, of course.
Yeah, sure.
Thanks.
Yeah, sure. Talk about shortcuts in VS Code. Okay. I think that's roughly the general thing that I wanted to talk about. I now have some more examples that we can go through. But what's really important for me for this first sessions is the message that there is a debugger, and you can really use it to interactively inspect the traceback. And the traceback is really consisting of these different levels of code depth. And each level can be seen as an isolated thing, and you can enter these levels and inspect them. And these help you then to understand the error. Okay, perhaps now we would go to an error which is perhaps of has a more complex structure. Let's go to our bug base. I'm sorry, I'm having a small cough. And here I have written down some buggy functions which we can try out with our bug tester. Sorry, bug hunter. Oh yeah, I have the bug tester. Perhaps before we do that, let's go to the bug tester that I have here. The bug tester. This is pretty much related to the execution as we know it via Python. But in this, for this time, we would actually open up a second shell. And instead of running Python, we would now run Pytest. And Pytest is a very powerful package that I think is not installed per default when you install Python. It's a standalone package. It's very close to unit testing. It has some different logics, but it's very powerful, and we can call it. And Pytest would run functions that are defined with a function prefix or a function name prefix with test or called test. So whenever you have a function which begins with the word test underscore, or perhaps even not underscore, but test, then the function is tested via Pytest. And this function may then raise an error, but the code still, or the remaining functions, the remaining test functions are still executed. So it's not as if you were executing this code with Python where you stop at the first error that you hit and the rest of the code is ignored because you're stopping there. It is instead running all these test functions one by one. and then reporting you back how many of these test functions were actually executed well or without complications, which of them were having problems. And we can call this now with Pytest bug tester py. Bug tester py, that's the name of the script that we're seeing on the left. And what it would do now is it would go through, or it would execute all these test functions and report us back which were successful and which were not successful for raising an error. And I'm hitting enter, and I'm seeing, oops, some, oh yeah, this is my bad, some late changes, bug, oops, sorry, bug, hotel, import function A. That's better because it's defined there. Okay, we have now corrected the import, and I'm clearing this again, and let's call the Pytest again. And now let's remove the breakpoint. And then we go again. Okay, now we're here again, and we're running Pytest, and we're hitting some errors. We're seeing here our Pytest report reported us, okay, there's 3 functions. You see this for each function that is tested, there's reported back one symbol here. Dot is for successful execution, and an F is for buggy execution. There was an error hit. And for each of these errors that were hit throughout the testing routine, the errors are described below. Now, here you see the report from test function A, which we'll call function A because we know this is a buggy function. And this would now report us back, what's the error here? We're again seeing some shorter traceback in condensed form. And then we're seeing the function or I don't know if it's always printing out the whole function here, but a longer level description of the spot where the error occurs. So this is the report from Pytest, which is very close to the traceback as we know it. And it gives us this important information here. So 3 of these wonderful, beautiful, buggy functions failed, and that's fine. And what we can do now in order to understand a little bit better on how these functions evolve, how this error occurs, we can interactively explore it again by passing a argument which is PDB. And PDB, that's you saw that before. It's the debugger, the Python debugger. And what it would do now is it would execute these test functions, and now instead of going through them, we're again stopping at the first error that we hit, but in debugging mode. And this is what we're doing now. And you see, there was now raised 1F. Okay, that's the first bug that we're finding. And then we're stopping here, and we're seeing our traceback of this very error. And now you know this is the Python debugger shell that we're now having here. We can go up, we can go down, and we can explore the things. Probably we have Z here defined, Y defined. Yeah, Y defined. So we're now on the second last level, and you are now in your known environment, well-known environment that you also can reproduce with the debug call in IPython. Why I'm saying this here is that this very basic instruction now to this Pytest debugging mode is, as I find, a very helpful instrument to develop code in a test-driven manner. You can define functions that you know they will probably not work, and I will hit bugs here, or perhaps I can reproduce a bug from, I don't know, a community member that say, okay, this does not work. I don't know, can you help me here? Then you're reproducing the bug in the test function, and directly when you call it with Pytest, you can enter into the debug mode and see what's going on there. And then in the end, you also have the end product, and this is very helpful. You have a unit test that already covers the error, and you are on the safe side that this error won't occur again. You have a higher coverage of your code and so on. We all know that. So this is a quite powerful instrument for this test-driven development, which I would now not go into depth now, but for perhaps a subsequent session, this could be something that we are exploring in more depth. Okay, is there any questions here related to the Pytest and how to perhaps, I don't know, set Pytest up, anything about the script or how I call it? Let me know, please. Are you all familiar with the stuff? Seems so. Okay. Then perhaps as a last exercise, I would go into perhaps one more rather complex bug. We have here perhaps we're taking which one are we taking? Let's do the first one, the process, the data pipeline. We're taking the data pipeline from the bug base, and we're doing it with the bug hunter. Data pipeline, and I'm calling this again, and now I'm hitting an error. That's not the error that I want, I guess. Function A, function B, data pipeline, bug hotel, retrieving source code. Okay, this is actually, I have to. Yes, this is where we want to be. Here we have some error that occurs due to a wrong data type. And this is, again, here something you all know that these track bases look at first a little bit complicated, but you can now either click through the code here with these interactive links or clickable links, or you can enter the debugger. And for example, if I now click here on the process data part, I see, okay, this is where actually the error is occurring. It seems, okay, there is a type error. It says expected a dictionary. Expected a dictionary with this beautiful green bug. And it seems that this what was here passed into the function is not a dictionary, because it's saying, okay, if the instance is not a dictionary, then this error is raised. So what is then passed to this function here? And then we can have a look at the traceback on a little higher level, namely this one here. And we're seeing, okay, yeah, there is a part now in line 12. So this is here, where data is passed to the process data function, right? The one here on top. And it says, okay, what we're passing here is hello world as a string. But yeah, of course, this is not a dictionary, so this error will be raised, right? This is quite clear when you think through, okay, this object is the same object as here. And then, of course, this is not a dictionary. This will raise a type error. So we can, to make sure, reproduce that, or not reproduce, confirm that. by going again into the debug mode, and we're going then one level up. And now we at the spot where we are within this function here, the data pipeline. And now if we are looking at the data, we're seeing hello world. And we know, okay, if actually data is not a dictionary, then here this type error will be raised. So what we could do now is, let's say message hello world, and let's see if that actually now works. And I'm going back to the scripts. I'm calling, I'm writing it out here, data pipeline, I'm calling it, and now it works, right? Because we have replaced this string that was causing the error by a dictionary, and now the type error is not raised anymore. Right? So we can really go through the different stack traces, investigate what objects are there, and always having in mind what error in the end was actually occurring raised. These are different. These here are different examples, which I partially produced myself, partially with some clever machines. And I'd say we go into a last one, which is the pandas structured data array bug, which is a bit more complex because now there is a long traceback. You see, oops, okay, what the heck is going on here? Oof, long thing. Again, close your laptop, restart, and try again. No, this is not what you want to do. You want to read the error message. Something has gone wrong here. Please report, blah, blah, blah. This is an issue which apparently happens at pandas, on a pandas level. And we can now investigate it and try to understand it by going through the code. And again, we can do that. Let's do the debug mode. And what we're now doing is we're stepping through the code, but now not now on our level here on the scripts on the left-hand side, but actually now we're on a, let's say, deeper level or level that is not our code at least, but the code of the third-party packages that we have installed. For example, here now we are in the core of Pipestar, internals, blocks, Py, and we can now perhaps just have a clue or have a guess what is going on here. Oof, yeah, there seems to be some NumPy arrays which and the type is checked and something is going wrong here. But still, it's not important what this error is about. I just want to show you that these errors can occur in third-party packages, and sometimes they are related to third-party packages. Sometimes they are related to your code that you wrote down, and you sort of misuse then some of the functions of third-party packages. And this is really a case-to-case detective work that you have to do then in the end to find out where the origin of the error is. And in this case, for example, it is an error of pandas, which is not at all a critique also. I just wanted to show you that this is something that can occur, and it is quite normal. And in this case, you might want to understand what's going on here. It's sometimes also very helpful to make a deep dive into third-party packages. In particular, I'd say when these are developed by ourselves or in our community, and then this is something you should do to understand whether the issue that you're facing is actually something more generic that should be solved within the third-party packages or in the side packages that we develop, or is it your code that is actually producing the bug? Okay. I would then stop here. And then open up for questions, remarks, and whatever you have, additions. Yeah, please let me know.
Fabian, maybe a question on how would you actually then like try to work on fixes in the dependencies? Like now you discovered this issue in pandas. How would you approach the fix?
Yeah. Okay, this is a very complex thing. The Pytest community is actually aware of this issue. It has to do with structured D types in NumPy and the missing compatibility here. So this is perhaps a bad example on how I would fix it, because probably it's opening Pandora's box. But if it's not as complicated, and most of our development and our packages shouldn't be that complicated, it's really about understanding the code. And perhaps then in the next session also, or in some of the other sessions, we can go on actually how to manipulate code, fix code on our packages and then propose a fix. But that would also go then into package development a little bit more and touching GitHub and branches and so. Yeah, what do you think?
Sounds good.
Yeah.
Maybe related to this, in that session, it would be also really interesting to see how you would open a third-party package script then inside of your environment, inside of your IDE, so you can actually look at the changes that you might be making if you want to contribute a fix.
Sure, yeah, definitely. That's a good idea. Perhaps just for sometimes it's not working. But again, perhaps in that regard, you can always go into your installations of your side packages. You shouldn't alter them, but you could, because I mean, now here I'm in the installed source code of my pandas package, which is under the path as we know it. So it's in now conda in the side packages. So this is where the source code of pandas, of my installed pandas, is. And I could now, of course, say I can alter this code and say, okay, I'm rerunning this now, and I should see a hey there at the beginning because I just made this printout. Here it is, right? So I have you all have the power to change your packages as much as you want. You shouldn't do it on the installed ones. You should rather do it on then forks that you have defined for yourself in sort of development, in a development environment. But still, it's something that you all can do. All the source code is on your computer, and you can always do the deep dive there. But yeah, I think that's a good topic for one of the next sessions on how to develop third-party packages and how to fix code there. What I wanted to say here really is that nonetheless, where the code or the traceback actually is, you can always jump into the code. I mean, except there is sometimes binary code so that you cannot debug. But as long as it is Python, you can always go into that code and also try to fix it. Okay, I'm rewriting that one.
Fabian, maybe just as a question, like comparing that to the VS Code internal debugging, yeah, like how would you, or like what are you actually preferring, or like what's your preferred way to debug in general?
Yeah, I come from another world regarding the debugging. I previously used Spider very much, and I still love the package. I just find here that there's some more flexibility with environments and folders and whatever. And there it was always using the debugging mode as I note. Okay, it's not true. It's not entirely true. They also have a sort of an ID debugger. And I know a lot of people using the VS Code debugger. And I think it's also super, super strong. It just feels to me sometimes a bit laggy, especially when you're having like long code with a lot of dependencies and whatever. Sometimes it can be a bit overwhelming. This is why I personally like the minimalistic way with the debugger. But of course, we can also go make a session about the VS Code debugger. Would that be something? Because
Could be cool.
it's really about then also how you structure the debugger in your IDE. I mean, there's different strategies on how to inspect variables, and so, and I think that's a longer thing to discuss.
But it's not what you're using at all.
No.
Okay.
Fabian, if you don't mind, like a provocative question. By any chance, are you aware of any AI-based tools which could be useful for debugging?
Oh, it's not at all provocative. I mean, I think it's super powerful when you put them into place correctly. I mean, I'm also just sometimes like copy paste the traceback into Claude or ChatGPT, and sometimes it's really giving me good answers. Perhaps Lucas can make a session about how to use AI in debugging. But I think that would be a super nice topic.
Wow, great to hear that there may be here something useful.
Yeah. No, I really recommend just to play around with it. Like sometimes when you're hitting errors and it's hard really to understand what's going on, just to copy paste it into some of these machines, and sometimes they're really giving you good answers.
At least you know that you are not alone. Thank you.
Yeah, that's true. Perhaps I stopped sharing my screen and I switched to my to Discord. Is there any other questions? Oh yeah, Lucas has already left. I think that was not too much news for him, but I think if he wants, he could also take over some of the upcoming questions, in particular about the AI. I think that he is really super strong.
Super, thank you.
On a rather general picture, how do you think is the format? Should we make it shorter, longer, more interactive? It might be a bit boring just listening and not doing things by your own.
I think it's cool. Like I guess like when we touch the packages and the models, and like this is where the people actually have their own problems. It's becoming more relatable. Then I think we get definitely more questions. Yeah, and if everyone has here also recommendations on like what thing you want to learn about, please share it with us because we just want to make more and more sessions. So each of those sessions will be recorded and uploaded to YouTube, and that way we don't have to repeat and teach people every time the same thing. We just share links.
Good point. Yeah, Davide also asked the question about how to use Copilot, and I think that's also a very good point. Yeah.
For me personally, it has been like music. Thanks a lot, Fabian.
Oh, thank you very much, Katja. That's very kind. Awesome. Yeah, then let's perhaps in the new year let's think about a good next topic. I mean, I think this has to be also something that we want to try out, and perhaps we can find a good approach on the format itself. I'm also happy to take over the next session, but then if another person comes in, I'm also very happy about support here. Oh yeah.
All right, very nice. Then thanks, Fabian. Thanks everybody for joining. Yeah, I think have a nice Christmas and a good festive break and a new year. And yeah, make your nice plans for the next year. Set good goals and. Oh, that feels cool.
Great.
Amazing.
Yeah.
Thank
Okay,
you.
and also from my side, thanks for listening, everybody, and I hope that at least give you some inspiration.
Thanks, Fabian.
Cheers. Bye bye.
Definitely. Okay, thank you.
Thanks.